Picture this. You're carrying a tiny, seemingly completely harmless vial onto a commercial flight. It's not explosive, right? It's not highly flammable. It's definitely not a biohazard. And yet, if even a tiny bit of this specific substance spills, it will completely ruin the flight in itself, destroy it. Honestly, that is a pretty terrifying thought, isn't it? I mean, look at it. It literally just looks like liquid silver. It is completely mesmerizing. So what makes this metal so unbelievably dangerous that it's strictly banned from airplanes? Like, what kind of hidden chemical superpower does it actually possess to get that kind of extreme treatment? Let's figure it out. Welcome to today's Explainer. I am so incredibly pumped to walk you through this one because it is fascinating and honestly a little bit scary. We're looking at the anatomy of a destruction when liquid metal meets aluminum. We're going to break down this wild experiment that exposes just how vulnerable our everyday materials are to a totally unassuming chemical saboteur. Let's get right into it. Section 1. The aviation threat, a beautiful but deadly substance. Okay, so let's dive into gallium. This stuff is a total paradox. It's beautiful, it's fascinating, but man, is it deadly to the right materials. Now, you probably know about mercury, right? That other liquid metal that stays melted at room temp. But mercury is super toxic to humans. Gallium is the complete opposite. In the experiment, they actually hold liquid gallium right in the palm of a gloved hand. It just melts beautifully from regular body heat, kind of squishing around like liquid gum, and it's totally safe for us. In fact, it starts freezing the second it hits the cold air. But if it touches aluminum, oh boy, it turns into a highly specialized destroyer. And get this, it is not cheap either. 10,000. That is the cost in rupees for just one tiny little vial of this stuff. Because of its totally unique properties, gallium is incredibly rare and highly prized. You don't just stumble across this in your garage. It's an expensive, precision chemical tool, which actually makes the sheer scale of the experiment we're about to look at completely mind-boggling. So how does this attack actually work on a chemical level? Well, it all comes down to one word, amalgam. See, gallium on its own, totally fine. But the second it meets aluminum, it aggressively tries to form a new alloy, an amalgam. This reaction completely ravages the aluminum's structural integrity. It takes this rigid, tough metal and alters it, making it so incredibly brittle that it literally breaks into tiny fragments. It basically rots the metal from the inside out. Section 2. Preparing the target. Bypassing the defenses. Now, you can't just splash gallium onto a metal surface and expect instant fireworks. For this experiment, the target is an older model iPhone, chosen specifically because its body is made of raw aluminum. But to get the gallium to do its dirty work, they actually have to violently bypass the phone's built-in defenses. Step 1, they literally mutilate the back of this perfectly functional phone with deep scratches just to tear through the colored protective coating. Step 2, when scratches aren't enough, they take heavy sandpaper and vigorously rub it down to fully expose that raw, vulnerable aluminum. And step 3, since it's winter and gallium solidifies really easily, they actually have to submerge jars of solid gallium in warm water just to melt it back into that liquid silver state. And then comes the pour. Remember that tiny 10,000 rupee vial? Yeah, that wouldn't be nearly enough for the dramatic reaction they wanted. So they use what they jokingly call a titanium army-level amount. Just imagine a massive jar, completely full of liquid gallium, being poured heavily all over the deeply scratched, exposed back of this iPhone. It completely coats the device, pooling all around it like a giant liquid mirror. Section 3. The waiting game, incubation, and false starts. You'd probably expect instant bubbling destruction right then, wouldn't you? But, chemistry requires some patience. Think about the timeline here. Day 1 is the application, the scratching, melting, pouring. They plan to just let it sit undisturbed. But then, Day 2 hits, and they run into a massive wall. Complete reaction failure. It literally takes until Day 4 to see the final destruction. So, what exactly went wrong on Day 2? Well, winter happened. The experimenters came back on Day 2, only to find that the freezing cold had totally stopped the chemistry in its tracks. The gallium had actually frozen solid. It formed this rock-hard, steel-like shell right over the phone. They basically just molded a super heavy metal case for the iPhone. And the crazy part? When they peeled those frozen chunks off, the phone was entirely functional. Screen turned on, speaker worked perfectly. Because gallium only attacks aluminum when it's in a liquid state, the winter cold actually saved the phone, at least temporarily. So, to get this chemical sabotage back on track, they had to make some quick adjustments. Step 1, melt the gallium again. Step 2, make sure the environment stays warm enough so the metal actually stays liquid and eats away at the amalgam. But step 3, this one is a super important safety measure. They realized that leaving an active, fully charged lithium battery inside a phone that is actively dissolving is pretty much a recipe for a massive explosion. So they smartly hit record on the camera, forcing the phone to shoot continuous video just to completely drain the battery dead before the reaction really kicks in.
Section 4. The shattering reveal, the aftermath of the amalgam.
And this brilliantly illustrates the sheer, terrifying power of this reaction once those conditions are finally right. After 4 long days of incubation, the results are in. And when they pull the phone out of the liquid bath, it is a sensory shock. The experimenter practically yells, "The aluminum is breaking into fragments. See? The entire back cover, what used to be tough, solid aluminum, has completely melted away into the tray. What's left of it effortlessly crumbles in his hands, literally like dry crackers. The once sturdy body of an iPhone turned into an absolute mess of brittle dust and fragments." But honestly, the autopsy is the most fascinating part of all this. Gallium is basically a surgical destroyer. Take the camera module, for instance, completely intact. The drained lithium battery, totally unharmed, it just falls out as one solid piece. The buttons, you can still press them. Gallium literally does not care about glass, plastic, or battery parts. It only targets the aluminum. And that body is just a completely shattered mess. It perfectly proves just how highly specific this amalgam reaction is. Which brings us right back to that terrifying warning from the beginning of our explainer. Staring at the crumbled dust of that smartphone, the experimenter lays it out perfectly. Even the airplane body would melt over and fall like this. Think about it. Commercial planes rely heavily on aluminum because it's strong and lightweight. If liquid gallium spilled and touched the raw aluminum frame of an aircraft mid-flight, it would trigger this exact same chemical rot. No massive fire, no explosion. The metal would simply lose all its structural integrity and literally shatter into fragments in the sky. It is a massive wake-up call about the hidden rules of chemistry governing our world. A substance that looks beautiful, shines like a mirror, and is safe enough to melt right in the palm of your hand can absolutely obliterate solid metal under the right conditions. So I'm going to leave you with this final thought. If just a handful of gallium can surgically destroy a smartphone and genuinely pose a catastrophic threat to a commercial airliner, what other invisible chemical threats are surrounding us every single day, just waiting for the perfect reaction? Thank you so much for joining me for this explainer. Keep asking questions and keep learning.